Good evening, we enthusiasts. We have been traveling a lot, we have been flying, we have been moving in warships, we have had amazing journey till now. And if you have ever traveled in an airplane and if you have peeped outside the window and ever wondered how planes move ahead, how does a jet engine work? How much energy does it require? How much potential energy do you have? What is this work? Have you ever wondered how a jet engine works? Come on guys, keep the chat box active. Let me know, because today we are going to talk all about work, power and energy. With me, your master teacher for physics at Vedantu. And remember guys, this is a very interesting code. You have to work very hard in silence, but understand, let that silence make that noise later on. So this is what we are going to do over here. Let our hard work be not seen right now. It's okay, but eventually, be it 2021 students, be it 2022 students, your results are going to speak for yourself. So welcome aboard everyone. This is Shreyas here, your master teacher for physics, and today I'm going live from my home. Finally the studio has been set up, and if you have checked out my Instagram handle Shreyas_Vedantu, then probably you would have already seen the studio setup. In case you haven't, go ahead and check it out. So meanwhile, just let me talk to all the students. Let me get the chat box working. Just give me a second guys. Just give me a second, I'll be just getting the chat box up and running. One second. Yes, 1 second. I cannot read your chats. Just 1 second, because today is the first day at my house where, yes, 1 sec. Let me just get this chat box up and running. Okay, yes, now I can see it. I can see all the students. Hi, Riddhi, Techno, Jumna. Hello, Akansha, Akhil, Juhi, Krito. Welcome aboard, everyone. Welcome aboard. So, yes, this is my new setup. So, yes, so today is the first time I'll be using this setup. Hello, everyone. Hello, Kashyap. Hello, Surudhi. Hello everyone. Welcome aboard. So I hope you guys are very excited to start the new chapter. And guys, the drills discussion will come up tomorrow. Do not worry, of Newton's laws. So all those of you who are very new to this channel, let me tell you, we give you assignments which are called as drills, right? And then this series is called as flash. So you get something called as the flash drills, and the link of it which will be put up in the description box below. Not in this lecture, but in the previous lecture you will see the drill discussion link of the previous session. So you can just have a look at it. You can download the PDF, start solving, because tomorrow I'm going to discuss all those questions which you have solved. And I know some of you have also mentioned the answers in the comment box below of the previous session. So I'm going to reply and I'm going to check all the answers very soon of the previous session. So do not hesitate from commenting below, and make sure all your answers are there, and I'm going to see all your answers in the comment box of the previous session. All right, so today we're going to start work, power and energy. Very good. Hi, hello, Sai Reddy, Faizan, welcome. Hi, Papi Reddy. Hi, Akhil. Welcome. Yes, Faizan, I will change the lighting of the room. Yes, today is the first day, right? So I'm just experimenting, so the lighting might not be that great. It's okay. I'm going to work on it. Today is the first day. I'm just experimenting, so I'm pretty sure it will definitely increase. Yes, it will definitely increase. So anyways, let's get ahead with the session, guys. So in case you are new to the session, do not forget to subscribe, or else you will not get the update of the next session. Yes, okay. So just adjust with the brightness and the settings, guys. Today I will adjust the lighting and the brightness by next lecture very soon. All right, don't worry. Okay, so today we are going to talk about work and scalar product. then tomorrow energy conservation, then PE curves, then we are slowly going to go to circular motion, and on Sunday I'm going to conduct a special class on JEE advanced problems, because many of you are asking, sir, we want very difficult problems. So yes, I'm going to give you JEE advanced level problems or higher level or order thinking problems on Sunday, right? I'll tell you the timings of Sunday very soon, but don't worry about it. Okay, all right. And in case some of you were asking, sir, what if I want to join Vedantu? What if I want to get my doubts cleared? A lot of you have doubts. Sir, will there be a teacher who can solve all my doubts? Yes. Will there be a teacher who is going to guide me? Personal assistant, personal teacher? Yes, you get that. You get a counselor. And what about tests and test series? And what about booklets? And what about question bank? Yes, you will get that. And sir, what about replays? Yes, you will get that. Sir, and what about different examinations like BITSAT, KVPY, Olympiads, boards, etc.? Will there be preparation for that? Yes, you will get that. Sir, what if I want to learn in Hindi or English? Yes, you will get that. Will I get good teachers? Yes, you will get that. Will I get motivational sessions? Yes, you will get that. And all at a very affordable price, guys. If you're a dropper student, then the 6-month price, actual price is 51,000, but after discount, you will get it at a very nominal rate of around 227 rupees per day. That's for droppers, all right? And for the 2021 12th standard students, the 6-month course fee is 39,000 rupees. You're going to get 20% off on that. And when you do that 20% off and you do that math, it comes around 173 rupees per day. That's quite reasonable. You can see that. All right. And if you're a 2022 11th standard student, then you get again 20% off because of this festive season. The 1-year course fee is around 42,000 rupees, but after discount, you get it for 93 rupees per day. So these are the course fees, and you get all the things that I just told you about just a while back. All right. Okay. So having said that, all right. You can use this coupon code SHHPRO for getting 20% off in this festive season. The usual discount rates are around 5 to 10%, but this time we are giving you around 20% discount, which is a huge discount. So do not forget to use this coupon code, and the link for subscribing to Vedantu is there in the description box below. All right. So let's begin. Let's begin, guys. Come on, give me a thumbs up. Give me a thumbs up in the chat box. I'm reading all the chats. Well, Sudruti, why don't you try out the different videos or the different sessions? Maybe one of those links might work. I remember just one of the link was not working, but I think the other links will work. All right, very good. Come on, give me a thumbs up, everyone. So Revan, don't worry, real discussion will happen. That time you'll get it. Very good. Lots of thumbs up coming up. Excellent, excellent. Let's begin the session then. Let's begin the session. So, what is work? You might think, what is work? Is work this? Well, a person working at an office, that's your traditional work. And you know, in physics and in English, the same terms mean different things. I'll give you an example. Normally, when you ask your friend, what is your weight? He gives the answer in kgs, right? But in physics, weight is always expressed in newtons. It's the force. So same way, work in physics is work almost, but there is a way of defining it. And let's see what's the physics way of defining work. All right. So let's see what is the way in which we define work. So imagine, guys, there is a Pandu and he applies a force on certain mass and he moves this block. Yes, he moves this block this way and he encounters some displacement. So this Pandu has moved this block by applying a force of F on this mass M. Alright. Then the work in this situation is defined as force into displacement. How much force you apply into the displacement. So more the force, then you have done more work. If you have done more displacement, then also you have done more work. So that's the easiest way. That's your 9th standard way. I think most of you would have learned work is force into displacement. All right. Yes, Bhargav, we will do advanced problems on Sunday, and at the end of the session you will see the level of the problems will increase. So concentrate right now. I'm going to take it from basics to high level. I'm not going to go from high level and then come to low level or high level and keep it at high level. No, that's not what we're going to do. We always go from basics to high level. Alright. Now, if this is understood, what if Pandu pushes the block at an angle? Yes, Bhargav, this is for 2022. So what if Pandu pushes the block at an angle? Something like this. If you push the block at an angle, now if he does the same amount of displacement, do you think, guys, he has done the same amount of work? Do you think he has done the same amount of work? What do you think? Alright, Sai Reddy has already mentioned what is the work. Amazing. Yes, you will get the PDF, Akansha, for sure. More work or less work or same work? What do you think? No, so a lot of people are saying yes, he has not done the same amount of work. Yes, correct guys, he has not done the same amount of work. So if he applies force at an angle, then understand only a part of the force. Yes, remember every vector can be split into two components. So this force can be split into two components, and this component along the displacement is only doing work. So is the complete force doing work? No. Which force is doing work? Only that force along the displacement, and that means the component of force. So let's see. So I just asked you, should the work be the same? Obviously it is not. And let's see what actually is the answer. And many of you give the correct answer. No. Congratulations guys, congratulations. Very good, very good. So how do I calculate work? All right, so let's see that over here. And like I was saying, this force has two components. This component, if this angle is theta, will be F cos theta, guys. So F cos theta is along the displacement. So work is then force along the displacement multiplied by the displacement itself. So force along the displacement is F cos theta, and displacement is nothing but S. So that is nothing but work. That's purely work. And if somebody asks you what is a unit, well, you can clearly see force is Newton. So 1 Newton force moves by 1 meter. That is called as 1 joule of work. Similarly, there is another unit called as erg, but that is in CGS. So in SI, 1 Newton into 1 meter is 1 joule of work, and similarly erg is nothing but 1 dyne moves by 1 centimeter. Alright, I hope this is fine guys. I hope this is fine. Very good. I can see all of you are already answering many things. Excellent. I'm just quickly revising. I'm just building that confidence in you so that you feel comfortable. Immediately if I give you a very hard problem, then you'll be like, oh, what is this? What is happening? So I'm going to slowly warm you up, you know? Just like when you exercise, you first do basic warm up. So right now we are doing basic warm up. All right. So now theta, what is theta? Angle between force and displacement. All right. So now, is there a better way of representing all this? Is there a better way of representing all this? Yes guys, there is a better way of representing all of this. And see guys, what is mathematics all about? What are these operators? Plus, minus, addition, integration, derivatives. They represent an operation. Basically, plus means, oh, I have to add things. Integration means, yes, it is also adding, but adding of small things from this point to this point. Same way, I can define an operator, because think about it. I just told you work is force cos theta into displacement. Isn't force a vector? Isn't displacement a vector? But think about it, work is a scalar quantity. That's the problem. Work is a scalar, force is a vector, displacement is a vector, and I have to multiply two vectors. So I define a new operation, and that is called as scalar product or dot product. Why is it called scalar product? It should be obvious to you right now, because work is force into displacement. What is work? Scalar. What is force and displacement? Vector. So multiplying two vectors, I am getting a scalar. So I am going to call it a scalar product, and the operation symbol for that is dot, a simple dot like you showed for multiplication. That's why sometimes it is also called as dot product or just scalar product. Alright, so that's how it is. So let's see what this dot product or scalar product is shown by, and some of you might already know about it. I hope you guys are excited to know this. Alright, so let's see. So dot product of two vectors, how do I define it? Here is the thing. If there are two vectors A and B, it need not be force and displacement, guys, it could be anything. This is applicable for any vectors which can be multiplied. So if A and B are two vectors and theta is the angle between them, then the dot product is defined as A vector dot B vector. And what is the output of this operator? This operator says take the magnitude of A, take the magnitude of B, and whatever is the angle between both of them, just multiply it by the cos theta. It's just an operation. It's telling me on this side of the operation there should be a vector, on the other side also there should be a vector, and the output of that is nothing but the magnitudes product into cosine of the angle between them. That's all. Alright, so can you think about this? What would be A vector dot just A vector? If it was A vector dot A vector, what do you think the answer should be? Come on, I'm reading all your chats. What do you think A vector dot A vector should be? No, Sairati, think again, think again. It's not one. A vector dot A vector. A vector dot A vector. What is the angle between A and A? What is the angle between A and A? 0. So what is cos 0? It is 1. So think about it. It will be A into cos 0 degrees. Cos 0 is 1, so it will become A square. I hope this is clear. So cos 0 is 1. Very good. A lot of you gave the answer for the angle is 0. So cos of 0, guys, is 1. So that's why it will become A square. Get that thing straight. Very good. Very good. Similarly, let's say there is a vector C and there is a vector D and they are perpendicular to each other. Can you tell me what should be C vector dot D vector, guys? What should be C vector dot D vector? Come on, think about it. What should be C vector dot D vector? Very good, guys. It should be 0. Excellent. Because cos 90 degrees will be 0. So whenever two vectors are perpendicular, understand the dot product will be 0. Very good. What about this, guys? If I have E vector dot F vector and I have F vector dot E vector, do you think I can put an equal to symbol? Do you think they're equal or not equal? What do you say, guys? Are they equal or not equal? Come on, let me know. Very good. Yes, they are equal because E dot F is EF cos theta and F dot E is FE cos theta. It's one and the same thing. So they are nothing but equal. Excellent, guys. Excellent, excellent. Well, Astha, very good. Chalo, bahut hi badhiya. Very good. I have taken your name. Now, come on. Keep answering. That way I will be seeing your name. I will be noticing your name. Answer the questions. That's what I'm more interested in. Okay? Very good. Keep it up. Keep it up. So, we have seen a lot of properties. Let me show you some more. A dot B is AB cos theta. If angle is 0, then cos 0 will be 1. If angle is 180 degrees, think about it. Cos 180, what is it? Minus 1. So it will be AB into minus 1. So it will become minus AB. If angle is 90, then the dot product is 0 and A dot B is always B dot A because they are commutative. You can interchange, nothing will happen, it's one and the same thing. All of this you'll be getting in the notes plus something called as the extracts, which you all have already loved. Alright, so extracts is nothing but the summary, detailed pointers and formulas of the entire chapter, which I will be providing you after the complete chapter is over. That is called as flash extracts. All the formulas you will be getting. But do not forget to keep a pen and paper beside you and keep writing and scribbling so that it enters in your head, because this is not a movie, this is a session or a lecture. Alright, great. Let's go ahead. Now, let's talk about dot product of unit vectors because that is also useful at times. So, let's see what is the dot product of unit vectors, guys. So, imagine what are unit vectors around the rectangular components or the XYZ axis? A vector of magnitude 1 in the direction of x-axis is I hat. A vector of magnitude 1 in the direction of y-axis is called as j hat. and a vector of magnitude 1 in the direction of z axis is called as k hat. So it's a unit vector. So instead of traditionally putting this symbol on top of it, you put this symbol. This symbol stands for the one thing, and that is called as unit vector. So if I say a hat means it's a unit vector. And if somebody asks you what is the magnitude of this unit vector, it's obvious, it has to be 1. So that's a symbol to tell that, you know what, the magnitude is only 1 unit. Great, amazing. I'm loving this. I can see all your chats. Guys, we enthusiasts are amazing. I mean, look at that chats you guys are posting because you want to help each other. You want to be noticed. You want to be heard. I like it. Very good, very good. So now, the next thing is, imagine if I ask you, what is I cap dot j cap? Think about it. What is I cap dot j cap? Think about it. What is I cap dot j cap? Think about it. Oh, is it 1? Think again, guys. Think again. What is the angle between I and j? Think about it. What is the angle between them? It's 90. Yes, so it is 0. It's not 1. Be careful. It's 0. In fact, j dot k. Look at that. J dot k. What is the angle between j and k? It is 90. What is cos 90? It is 0. So it is also 0. And in fact, I dot k is also 0. All the perpendicular vectors, remember their dot product is 0. Do not forget that. Yes. Angle is 90. Excellent. Very good, Sai Reddy, Shivam, Akansha, Aarti, Pranav, Diti, Naman. Very good, Techno. Very good. Now, what if I tell you what is I dot I? What is I dot I, guys? Think about it. What is I dot I? Think about it. What is I dot I? I dot I will be, what is the magnitude of I? 1 into magnitude of I, 1 into angle between them, 0. So cos of 0. So what will it be? It will be 1. Alright? Yes, excellent. And it will be same as j dot j, or I can just put it here. Yes, this will be same as j dot j, and it will be also same as k dot k. So these are some basic rules which you should know. I'm pretty sure you would have got it by now. Excellent. So perpendicular things 0, same thing is 1, provided their magnitude is 1. Else it would have been a square or the magnitude square, which you have already seen. Alright? Excellent. Okay, so you should know this because sometimes you might get dot product related questions, because now you're going to see why dot product has been discussed, because just now we saw work was force into displacement into cos theta. So instead of writing force into displacement into cos theta, why not use this shortcut method and just write F dot S? Isn't that better? Isn't that concise? Isn't that understood easily? And can't we just use these rules to make things very simple? So that's why, guys, that's why. Let's get back to work and let's see how exactly work is represented. Alright, now the thing is, work is represented. Let me go back over there. Sorry. Yeah, so when the force was at an angle, alright, the same slide. So instead of saying work is Fs cos theta, I will better write it as F vector dot S vector. That's a better way of writing it. That's all. Alright, remember it. Now that we know this, please understand the value of theta will decide the sign of cos. And you would have learned this basic rule in trigonometry, all silver tea cups. When your angle is in the first quadrant, all ratios are positive. In the second quadrant, only sine ratio is positive. Third, tangent ratio is positive. And in the fourth, cosine is positive. So, if theta is 0 to 90, so everything is positive. So, cos theta will be positive. Think about it. Alright, cos theta will be positive in the first quadrant. Exactly at 90, cos 90 will be 0. But the moment it goes into this quadrant, that is the angle between force and displacement is obtuse, then cos of anything 120, 150, 145, etc. will be negative. So understand this cos theta, guys. Alright, so this cos theta will be positive from 0 to 90 degrees, and it will be negative from 90 degrees to 180 degrees, and exactly at 90 it is 0. Alright, so remember that. But what is the significance of that? What is the significance? Okay, positive work, negative work, nobody would have told you this. Today I am going to make you visualize what is positive and negative work, because that's what we stand here for. So going back to the same thing, let's get back to work. So what is positive work? Positive work means punya. You would have heard of punya and pap. Same way, positive work means this person applies force in the direction of displacement, or at least an acute angle. Even if he applies a force, yes, even if he applies a force in this direction, it's okay, because a part of it, yes, a part of it is in the direction of the displacement. So whenever the angle is acute, understand the work done is positive. He is doing punya, he is giving his energy to the block. He is doing positive work on the block. That's what it means. Acute angle, correct. So what is negative work? How many of you have seen this movie? How many of you have seen this movie? Spiderman stops that train. He uses his spider webs and he stops that train. He is applying a force opposite to the displacement of the train. What kind of work is Spiderman doing? Negative work. Remember this. Remember. Yes, looks like so many people have seen this. Excellent, excellent, excellent. So Spiderman is doing pop. What is Spiderman doing? Pop. Why? Because he is doing negative work. Why is he doing negative work? He is taking away energy from the train. Don't go morally. Morally he is doing punya only. But physics wise he is doing pop. Why? Because he is taking away energy from the train. Remember that. Exactly. Very good. Very good. Yes, he is taking away energy. More examples. Look at this guy. Look at this dude. He is doing positive work, but gravity is doing negative work. Gravity is sucking away his energy. Oh my god, he fell down. Okay, so he is applying force in the direction of displacement, but gravity is down, displacement was up, so gravity is doing negative work. Gravity is doing negative work. Yes, yes, gravity is doing negative work. Yes, on the same object, if multiple forces are acting, one of them might do positive, one of them might do negative. So it is possible. Different forces do different kinds of work. So keep this in mind. Alright? Okay, no work. What is the meaning of no work? Well, you push something, bechara, look at this guy. Oh my god. He is not able to push it. He is doing zero work. Why? Because no displacement. Bechara guy, okay? So remember this, you will always understand whenever that force is not able to displace, that is zero work. And there is one special example. If the force is perpendicular to the instantaneous displacement, like when a satellite or a moon goes around the planet, alright, the centripetal force, you will learn what centripetal is in circular motion. A centripetal force, which is like gravity or anything else, will be always perpendicular to the displacement. And remember, when force and displacement will be perpendicular, what will be the angle? 90. What is cos 90? 0. So what will be the work? 0. So this force never does work on this object. Understand that? Yes, correct, correct. And you will be like, sir, I am feeling bad for gravity. Bichara, gravity is acting on this satellite and it is not doing work. How sad, right? Guys, you don't have to feel sad, because actually that gravity is not doing work. What is happening to the speed of the satellite? It is always remaining the same. So, has it increased the potential energy? No. Has it increased the kinetic energy? No. Has it taken away the potential energy? No. Has it taken away the kinetic energy? No. So, if it has done nothing, why are we feeling sad for him? He has not done any work. So, be chill about it. Alright? Very good, very good, very good, very good. I am seeing that you guys are loving this discussion. You guys are loving this discussion. Excellent, excellent. क्या बात है, क्या बात है. Excellent. Yes. Now, awesome Boston. Loved it. Yeah, best session. Very good science. We have Champa aa gayi hai. Yes, ESG. Yes, ESG. Champa has come. Now, Champa is asking Pandu, and if you have not attended that session of non-inertial frame where I have discussed the love story of Pandu and Champa, you have missed something in your life. You should watch that session of love story between Pandu and Champa, that entire conversation, how he proposes Champa and how they go along, how they meet, and how they go in that spaceship. You should watch it for sure. Yes, anyways. So, Champa is asking Pandu, so what about energy? You have been talking about work. What about energy? So, for that, she's like, isn't it same like work? Isn't it same like work? No, it's not same like work, because though the dimensions are same, the dimensions sure are same, but energy is not work. In fact, energy is the ability to do work. I have energy. I just ate vada pav. So I have energy. So I have ability to use this energy to transform into work. So that is what energy is, and it's different from work, although the dimensions are same. The dimensions are same, but it's one and the same. It's not the same thing. It's different things. All right, but energy gets converted into work. So if you have energy, like if you eat vada pav or if you eat something else, I don't know, whatever your favorite dishes, you can just post it on the live chat out there. I'll be reading what is your favorite food. So if you eat your favorite food, you definitely will get energy. Alright, in fact, now we're going to see a theorem which relates work and energy, and that's the most beautiful part of this session today. What is the relationship between work and energy? Yes, let's see that. Let me see. Ice cream, paratha, milk, momos, pani puri, chocolates, chicken biryani, Telangana. Akhil, you can't eat Telangana, dude. You can't eat Telangana. I asked, what is your favorite food, not state? Okay. Biryani, idli sambar, vanilla ice cream, dosa. Joule is SI unit. Yes. Pizza. Navmi, you can't eat sadhya. Sadhya. Oh, it's not a name. Oh, okay. It's probably a dish. All right. Paneer, kya baat hai? Amazing. Bonda, it seems. Okay, Akhil ready. Finally, bonda. Okay. Nice. Samosa, that's my favorite too. क्या बात है, बहुत ज़्यादा भूख लग रहा है मेरे को. Please don't do this. Okay, let's stop. Let's not talk about dishes. I'll feel hungry then. Okay, so what is kinetic energy? First, let's talk about different forms of energy, but we are going to talk more about kinetic energy today. When you hit a ball using a stick or a bat, the ball gets kinetic energy. Energy in motion is called as kinetic energy. A stationary object does not possess any form of motional energy, but when it moves, it has motional energy, which is called as kinetic energy. And if this female out here, if she had hit the ball harder, then obviously that ball would have had more kinetic energy. And if the mass was more, then also it would have more kinetic energy, provided it moved with the same speed. So kinetic energy can get converted into different forms. It's not necessarily it stays there. We're going to talk about this in detail in the next session. But understand, a moving object possesses kinetic energy, and it can get converted into different forms like potential energy and so on and so forth, which we'll be discussing later on. But first, let's see the formula for kinetic energy. So, kinetic energy is basically energy of motion of a body. Okay, body at rest has zero kinetic energy, and the formula for kinetic energy is half mv square. But you can do a small magic, and that magic is nothing but half m square v square by m. Just multiply and divide by m. So think about it. What will happen next? It will become half. Yes, mv is nothing but, think, momentum. So it will become p square by m. So both are equivalent. You can use either this formula or you can use this formula. It's up to you. Either use this or you can use this formula. It's up to you guys. All right. Okay. So that's the formula for kinetic energy, and unit obviously is again joule, and it's a scalar quantity. It does not matter what direction it is. We can already see that m is positive, v square will be always positive, so kinetic energy will be at the most 0, but it will always be otherwise positive. Alright, yes. So remember both these formulas. These are very important formulas for solving problems. So let's go ahead and use this formula, because most of you would have already studied what is kinetic energy. So what's the theorem which relates work and kinetic energy? That is called as work kinetic energy theorem. So imagine a person pushing a block by applying some force, and because of which the velocity changes. Yes, when you apply force, what happens? It accelerates, so the velocity changes, and that's why I can relate them, and the relationship between work and kinetic energy is this. If there are many forces, right? If many, one or more forces do work, then it changes the kinetic energy of the body, and that is precisely what work kinetic energy theorem is. And you can see that the total work done, this symbol stands for total or summation, is nothing but the final kinetic energy minus the initial kinetic energy. Some people also like to write this as delta K. That is also okay, but we can stick to Kf minus Ki. So this is your work kinetic energy theorem. Now if you think about it, when that satellite was moving around the earth, the energy was always the same, correct? Kinetic energy was always the same. So what was the work done by gravity? 0. So final and initial both are same. The difference, change, will be 0. So work done, there was only one force, gravity. So work done was 0. Next, remember that person lifting up that thing, or person pushing that block, just like this example, he is increasing the velocity. If he is increasing the velocity, final kinetic will be more than initial kinetic. So what will happen? This term will be positive. So work done will be positive. So if you are increasing the kinetic energy, that net force is doing positive work. Similarly, remember Spiderman trying to stop the train? What would happen? The final energy will be less than the original or initial energy, so it will become negative. So the total work will become negative. So it kind of makes sense. Excellent. I can see everyone responding. Very good. Shall we start doing some problems, guys, now? Let's start doing problems. Let's get to problems. Believe me, I have some crazy problems, some eye-opening problems. Nobody would have taught you this. I most likely know that nobody would have told you about this particular aspect, not in this problem, in a problem ahead, and you'll see what it is, because those concepts are important for advanced. All right, let's begin. Yo, a lot of you are saying this and this. Very good. Read this problem. A rock drops from a height of 50 meters. What is the speed when it reaches the ground? Now, I'm pretty sure we have done this, but I want you to see it from a different perspective. That is why work energy theorem. Now, when this block falls down, let's think about it. Okay, so when this block falls down by a height of h, right, it starts from rest, of course, and it gains some velocity over here. I want to calculate velocity without using kinematic equations. Remember that. No kinematic equations, using work energy theorem. So first, let me write down what is work kinetic energy theorem. Total work done is final kinetic minus initial kinetic energy. So let's write that down. And now let's think, which are the forces on this body which are doing work? Think about it, the rock falls down. Okay, only one force, gravity. So only gravity. And what is gravitational force, guys? It's nothing but mg. Great. So on the LHS, I'll say work done by gravity is equal to final kinetic energy, which will be half mv square minus initial kinetic energy will be 0 because it started from rest. All right. So what is the work done by gravity? Okay, where is the force? Here. Where is the displacement? Down. So force into displacement into cos of angle between them. What is the angle between force and displacement? Oh, they are in the same direction. I think it is 0. So it is cos of 0 is nothing but half mv square. The good thing is this m and this m goes off and cos 0 is nothing but 1. So I will get v square by 2 is equal to gh, and therefore it tells me v is nothing but root of 2gh, which otherwise also I would have got. My point is, it's not 180. Anu, it's not 180. Look at that. Displacement is down. Force is also down. So it's 0 degree. Be careful. Yes. My point is, the answer won't change. And now you can substitute the values. It's not that difficult. What was the height? 50. So 2 into 10 into 50. So that's it, guys. Bolo kya aa jayega? 10 root 10, right? 10 root 10 meters per second. That's the answer. Yes. My point is you can do it by both the methods. That's what I wanted you to see. Very good. Very good. Amruta Science. Akhil. Yes, thank you. Very good, Sudhuti. Very good, Faizan. Faizan, it was not 10, it was 10 root 2. 10 root 10, sorry. Yes, yes. Very good, very good, very good. Chalo. Let's go to the next problem coming up on your screens. Now, okay, let's see how many of you can get this very easy. Lot of things are slowly I'm increasing the level like I promised you. A block of mass 2 kg is pulled by a string and the tension in the string is 40 Newton. It moves up by 2 meters. What is the work done by tension, work done by gravity, and the total work done by all the forces? Let's see how many of you. JEE I'll be starting by next month. First I'll be completing all the major chapters of 11 and then I'll be starting with 12th portion like electromagnetism and EMI and electrostatics, Gauss law, etc. I'll be starting with 12th also in December. Don't worry. First important chapters because these concepts are very important. Rotation, collisions, work energy, etc. Okay. So let's see how many of you can get this. Let's see how many of you can get this. I'm waiting for your answers. Shall I put a timer? Let me show you a very cool feature of this board which I have got today, and I think it has a timer as well, and let's see how many of you can solve this question in 1 minute. Chalo, the countdown timer has started and let's see how many of you can get this within 1 minute. All the answers, guys. I want all the answers. You can put a comma. You can put a comma. Come on, come on, come on, come on, come on. And put a comma. This much joules, guys. It will not be in Newton. Be careful. Work is in joules. You guys are giving the wrong units. All of you are wrong, guys. All of you are wrong. Put all the answers like this much joules, comma, this much joules, comma, this much joules. All the answers together. Don't put it separate. I won't understand which work you are talking about. Come on, come on, come on, come on, guys. Let's see. Okay, let's see. Only few people are putting the answers properly. Acha, Sonu. Time is up. All right, let's have a look. Okay, so here is the thing. Let's try and find this out. Okay, so first I'll start with the forces acting on the block. Okay, so what are the forces acting on the block? Well, one is obviously the tension. And how much is the tension? Tension is 40 Newton. So I'll put that. And obviously there is this weight. And how much is the weight? Well, the mass of the block is 2 kg. So it is 2g, which is nothing but 20 Newton. And this displacement is 2 meters. Okay, that's about it. Now, think what is the work done by tension? Work done by tension, very simple. Force, which is 40, into displacement, which is 2, into force and displacement in the same direction. So cos of 0. So hence it will become 80 joules. Most of you got it. Very good. Similarly, work done by gravity, force which is 20 into displacement which is 2 into force is down, displacement is up, so angle between them is 180 degrees. So hence it will become 40 but with a minus sign. So minus 40 joules. That's the answer for first two parts. Now the total. So the total work done will be obviously 80 plus minus 40, which is obviously nothing but plus 40 joules. So that is our final answer for, total work done. That's what it is. Is that clear? Is that clear? Everyone, very good, very good. I can see everybody answering this. Excellent. Kya baat hai, kya baat hai. Excellent. Now, like you all know, I like to vary the questions. Let's vary this question and let's ask a different thing, and you will see a different perspective of this. Yes, you're going to see a different perspective. Guys, I hope you have written down all these answers in the notebook, because once I go to the next slide, these answers won't be visible. Okay. So total work done, remember it was 40 joules. Remember that. Okay. So great. Let's move on to the next part. What is the change in the kinetic energy? Now I know I can use work kinetic energy theorem, but I am a little bit crackpot. I am not going to do it that way. I want to do it the other way, using Newton's laws, and see what happens. Just for fun's sake. Just for fun's sake, guys. Okay? And let's see what happens. So yes, the tension was 40 Newton. Well, yes, the weight was 20 Newton. So it will obviously have some acceleration. And guys, believe it, since net force is mass into acceleration, what is the net force? It is tension minus weight is the mass, which is 2 into acceleration. And what is 40 minus 20? It is 20. So therefore 20 divided by 2 is 10. So 10 meters per second square is the acceleration. Now what has been asked? Calculate the change in kinetic energy. Okay, so here is what I do. The change in kinetic energy is final, which is nothing but half. 1 second. This was 10. Okay, half m v square minus, I can just put it over here, minus half m u square. Let's take m common and half also common. So it will become half m v square minus u square. But do you remember by kinematics what is v square minus u square? Think about it. What is v square minus u square? Yes, it is acceleration into s into 2. I hope you remember it from kinematic equation. So half m into 2 as. You would have done this kinematic equations. Excellent. So what will happen? 2 goes off, and what will you get? mass, mass. Okay. So now just substitute and let's see what do we get delta k as. Mass is 2, A is 10, S displacement is 2. What is the answer? 40 joules. You should be so proud that you did not have to do all this had you known work kinetic energy theorem, because we just did it. Net work done, what was it? 40 joules. That's what I wanted you to see. That's what I wanted you to see. The total work done is the change in kinetic energy, not one work done. Not work done by tension or work done by weight. No. Total work done is the change in the kinetic energy. Amazing, right? Yes, correct, Anu. This method is like going from Mumbai to Delhi to Chennai to Andaman. Correct, very good. So you should feel very proud that you know work kinetic energy theorem. Excelente. Excelente, guys. Excelente. Okay, so that's what I wanted you to see. Now this is a very brilliant question. Let's see how many of you can get this. I'm going to put a timer for this as well. Let's see how many of you can do this. Countdown timer starts now. 50 kg person has walked 1 kilometer. What is the work done by the friction if coefficient is 0.4? Come on, let's see. Dilip, you can always rewind. Please concentrate on the current session, current question. All right. Come on, let's see. How many of you give the correct answer? What is the work done by friction? Come on, guys. Come on. Thank you, Hardik. Come on, answer this question. Answer will be in joules. Come on, 10 seconds to go. 9, 8, 7, 6, 5, 4, 3, 2, 1, and let's see. Oh my god, cat, please come later. Okay, let's have yes, don't worry, we'll get idea what is the answer. So now let me tell you a very important secret. Many people do not tell this secret. Keep it secret, guys. Okay, what is this secret? Should I tell you this secret? Okay, here it is. Work is F dot S, correct? What is F? Force. What is W? Work. But I'll tell you something which nobody would have told you. You know what is S? Well, you'll be like, sir, come on. It is displacement. No, guys, it is not displacement. Like, what the hell? Sir, did you lie to us? No, I didn't lie. I just didn't tell you the complete truth just some time back. So I'll tell you what is the complete truth. Should I tell you the complete truth? It is not displacement. No, it's not speed. It is displacement of the force. It is the displacement of the force. Yes. A lot of people do not know this, and that's why they get a wrong answer. Think about it. When I was pushing the block, my force also moved with the block. So the displacement of the block and the displacement of the force both were same, so you never really bothered. Correct. Think about it. When you were pushing, the force and the block moved by the same amount, so you never really bothered about it and never really made a difference. But here it starts making a difference. Now think about it. When that person is walking, the frictional force, okay, no problem. The frictional force acting on his feet, wherever it is, doesn't matter. Let's say, for the time being, example, he's pushing the ground behind. So on him, example, the friction is acting front. Think about it. Till the time his next leg comes there, is this friction moving? Is his feet sliding? Think about it. Is his feet sliding? When you walk, do you drag your feet? No, right? You put your feet stays there, and your next feet goes on to some new place. Till that time, just try walking, guys. You will realize it by yourself. Your feet do not move with respect to the ground. Yes, the feet do not move with respect to the ground. So, what is the displacement of friction? Think about it. What is the displacement of friction? The answer is 0. It's not there. It's not moving. Friction is there till the next foot comes. And then a new friction comes. And that friction doesn't move. And that also has 0 displacement. So what is the work done by friction? It is 0. That is the answer. That is the answer to this question, 0. Believe it. You'll be like, sir, what the hell? My whole life has been a lie. I thought friction is the bad guy. I thought friction is the villain. But now you're telling me friction is not the villain. So then please tell me, why did I eat a vada pav or idli sambar or pizza or ice cream and I gained some energy so that I could walk this 1 kilometer? Why did this person have to eat? If the friction is not the villain, he's doing no work. The answer to that is, you did not do work against friction. You did work in just moving your muscles. Just imagine if somebody lifted me up like this. I was in air. And if I had to just do the actions of walking, won't I consume energy in muscular movement? Obviously I will. That's it. Done. So just think, again I am put down on the ground. That's it. Now I'll still do the same action. I will still consume the same energy. So where is my energy going? In muscular movement, not in friction. I hope this is clear. Amazing, right? What a technique. What a technique. I love this problem. So no wonder. Okay, one sec. No wonder this cat gave this reaction. Got it? Akhil, all these things probably I'll have a one-to-one personal session where I will answer all your queries. Don't worry. We'll have a one-to-one interaction on Instagram or something. So guys, please check out my Instagram. आज मैंने पूरा स्टूडियो का इतना मेहनत से वीडियो लिया है, अमेजिंग वीडियो लिया है. Do not forget to check it out on Instagram. Shreyas_Vedantu. Yeah, I'll be waiting for all your comments and replies. अच्छा, चलो next. Work can also be measured using integration. So this is the last type of problem. Let's get done with this. Work done using integration. Yes, you can do that. Integration is always there. Now, we have seen what integration is some days back, and let me tell you that if you have a graph of force versus position, and let's say this is my initial position, and let's say this is my final position. This graph tells me how my force changes with position. You can find work by finding area under the force versus displacement graph, or force versus position graph. Yes. So remember what area was? Area was integration. And how do you get area with integration? Yaad karo, definite, indefinite. Oh, limits. Remember upper limit, lower limit. Where does limits come? Definite or indefinite? Obviously definite. So definite integration, force and displacement and initial position to final position. So that is the formula for work. Alright, so that is the formula for work. This is something which you should remember. Alright, let's do some problems. This is a formula. Now let's see how to apply it. Yes, definite integration. Correct. Very good. Excellente guys. Excellente. क्या बात है? चलो चालू करते हैं. Let's start with problems. Now that you know work is integration. Oh my god. Looks scary, but don't worry, it's not scary. Okay? Read it. A particle of mass 2 kg starts from rest along the x-axis. Force is given as function of displacement. What is the work done in 4 meters? Okay, let's try and do this. I don't think it should be difficult. Read the question carefully. What is the work done in 4 meters? Okay, so 4 meters, first see. 4 meters is here. Now, this is force versus x. So I think we should calculate the area only till here. So just guys understand, we need this much area only. We need this much area only. Okay, so let's see how much is this area, guys. How much is this area? Okay, how do I calculate that area? So work done is area till 4 meters. It's a trapezium, so you know the formula for a trapezium. Half multiplied by sum of parallel sides multiplied by the height or the distance between the parallel sides. So think about it. What are the parallel sides? One is 2, okay, and the other side is 4, and the height, okay, the height guys is nothing but 40. Okay, so I think you should get the answer. 2 plus 4, 6. 6 into 20, how much is it? Come on, 120. Very good, you guys have already given the answer here. You guys are very smart. Excellent, that is the work done. How easy it is. You will never forget if you study under me. That's it, that's simple. Area under, okay, force versus displacement gives you work, and it is positive. If it is positive, that means the graph is on the top. If this is force, this is x, and you somehow see that the force graph is something like this, then understand this area will be negative area. Okay, be careful. So when it is below, it is negative. When it is on the top, it is positive. Be careful. Okay, okay, great. Chalo. Now the next part. What is the speed of the particle after 4 meters. Okay, it looks like an easy problem to me. Let's try this out. What is the speed of the particle? I just know work kinetic energy theorem. The work done is final minus initial kinetic energy. What did I just calculate the work done to be till this 4 meters? I think I just calculated the work done, and that answer came out to be 120 joules. Okay, great. The particle starts from rest. Matlab initial kinetic energy will be 0. Okay, so initial kinetic energy is 0. Final energy will be half mass into V square. Great. 2 cancels. So V square is 120. So V is root 120. If you want, you can simplify it, but I'm just leaving it here because mathematics is the part which you can do easily. Easy peasy. Amazing. Akhil, there is no rule that we are going to conduct the lectures for 1 hour. We will take the lectures as long as we need it. Yeah, please understand. Yeah, and I'm pretty sure as we enthusiasts, we are always enthused about learning. One day though I want to conduct a lecture in the midnight, yeah, sometime. I don't know, someday. What say guys? It will be so cool, na, meeting at 12 o'clock in the night. ऐसे, maybe not studies, maybe ऐसी गपशप के लिए and थोड़ा हल्का फुल्का पढ़ाई. Amazing it will be. You would never have probably attended school in midnight, or maybe some of you would have. How cool it would be to have a lecture in the night. By the way, Vedantu has done that. We had midnight revision series for 9th and 10th standard during the boards and before the boards and all that. Full 24 घंटे पढ़ाई board से पहले. मजा था वो. Yeah, midnight will be so cool. Yes, one day we'll do that, huh? Okay, chalo. Last problem, guys. Yes, last problem for the day. Get ready. Let's see how many of you give the answer. I'll put a timer. Let's see how many of you give the answer. Particle 6 kg moves with x is equal to 2t cube. Derivatives is there. Yes, derivatives. I give you the hint. Shh, I've given you the hint, guys. Derivatives. What is the work done in the first 2 seconds by the net force on it? I'm going to start the timer, guys. Come on. All right. Shall I start? Come on. Within 1 minute, you should give me the answer. Let's see. Okay. Let's see. Chalo. I'm starting. 1 minute to go. Let's see how many of you give the answer. Yes, Ankit, don't worry. We are going to come up with a strategy session for 2022 also. Come on. Let's see how many of you give the answer. Maruti, for now, let's assume that it will be held in January. Okay. Many of you have given the answers. Sudriti, Akhil, Saurav, Sanya, Puneet, Ankit, Pranav, Saurav, kya baat hai? Let's see how many of you are correct. Guys, keep a tab on everyone, huh? Let's see who is correct. Let's see. Okay, let's see. Come on. 10 seconds hardly. No problem, Ankit. अच्छा 2 सेकंड बस खत्म हो गया. I love this sound. It's so pleasant. Okay, now let's have a look at how to solve this particular question. So x is given, work is asked. Remember work kinetic energy theorem? Use it. As simple as that. Yes, no need of integration. You can use derivatives. How? Look at this. X is 2t cube, but v is derivative of x with respect to time. That means it is d by dt of 2t cube, and we know that 2 just comes outside and it's just the derivative of t cube. So it will become t cube's derivative, guys. Use x raised to n formula. N comes outside and x's power reduces by 1. Okay, so it will become 3 into t square. So it will become 6t square. That's the velocity. Now work done in the first 2 seconds. So what is the velocity at 2 seconds? Use this. 6 into 2 square. 6 into 2 square. 2 square, guys, 4. 4 6 are 24 meters per second. V0 मतलब initially 6 into 0 square, that is 0 meters per second. Now, because we have to calculate work, guys, why not use this? Work is half m v2 square minus half m v0 square. Change in kinetic energy. Just do that, you will get the answer. What is the mass? 6. What is the velocity? Well, 24 square minus 0. So that's it. Do the math, come on, and let me know what is the answer. Come on, guys, what is the answer? Okay, finally people are given. Very good, Maruti, Saurabh, Anu, very good. Yes, it is 1728 joules. That is the answer. That is the answer. Yes, correct. Revant, the drill will come in the next session, okay? And the previous drill link of Newton's laws friction is there in the previous video. This video does not have a drill. 2 videos have plenty of questions together which we'll be giving you tomorrow. Alright? Okay, very good. So, let me remind you guys what and all we have done today. One sec. Okay. Yeah. So, today we have done work and scalar product. Tomorrow we are going to do many problems on energy conservation, and together these 2 sessions you will get a drill tomorrow. Okay. And tomorrow also I'll be uploading the drill discussion of Newton's laws. In the morning you'll be getting it, and the remaining parts are given over here. On Sunday there will be a special session just for JEE Advanced students, right? JEE Advanced, understand, difficult problems, because a lot of you have asked for it, and those of you who want to subscribe, do not forget the link is in the description. You can use that link and get into Vedantu. You can get all the test series, questions, doubt sessions, everything, whatever you wanted is available in the description link. And remember, the coupon code is SHHPRO. It's a limited offer, I'm telling you. Baad mein mat puchna, sir, please give me discount. I cannot give you. That time I'll give you 5% and 10% maximum. Okay, so this is a maximum discount I can offer you right now. And Telegram group link is also there in the bio. In case you are not able to find it, use this one, https://vdnt.in/venthuse. That's the link. You can type it out, or you can use that one in the description below. Okay, so I hope you have liked this video. If you have not yet liked, please like it. Go ahead, like it, because remember, what is the fees for the channel? Your likes. Alright, do not forget, your fees for this channel are your likes. And if you are a new time user, please do not forget to subscribe, else you'll be missing out on all the stuff. Okay, bye bye guys. Well, Akhil, my branch was mechanical engineering. Yes. Bye bye, take care guys, bye bye, take care. See you. This was Shreyas here, and I was going live from my home. Yes, this is the studio at my home. I'm from Bangalore. Bye bye, take care, see you, have a great night, sleep well, study well, stay home and stay safe. Take care guys, bye bye.